Ladies and gentlemen, welcome to this very special episode of the Deep Q Cast. We're actually really happy today because we, for the first time in our podcast history, have a very special guest. We are very thrilled to have our very good friend Avi Palley on the podcast today. Avi Palley is single-handedly one of the most genius and best programmers I have ever met in my entire life. We had a very close professional working relationship together at a past life at Bank of America where we worked on the same team. And, we wanted to continue the conversation that we had the last episode about how to build trading systems that were geared for treating data as a first-class citizen. And I couldn't think of a person more qualified and more competent when it comes to building out trading systems, the treatment of data in the proper way, and making sure that it's thought of from front to back for all the end users of the system. So I'm going to let Avi give a quick intro about who he is and why he is uniquely qualified to talk about trading systems, both in TradFi and in crypto. Avi, let me turn it over to you.
Great to be here, Carlos. Thanks for the kind intro. As you mentioned, we worked very closely in a previous life back at Bank of America in electronic FX. That was my initial, foray into quant finance and data. But prior to that, I was actually entrenched on the technology side at Bank of America, specifically in FX options. And I was pretty exposed to, trading systems, but not so much data. I moved into electronic FX, which is obviously a very highly data-driven business. All electronic trading is by definition data-driven. When I did that, I realized that a lot of the best practices that people kind of take for granted in technology and, building trading systems, for whatever reason, seemed to get put on the side when it comes to data. When really, good software engineering principles are just as important when you think about data and when you think about, data workflow as it is for anything else. So I put a lot of attention and effort into applying those principles to data to a lot of success. And that was in FX. I then moved into crypto. I was very excited to, bring a lot of that TradFi experience into the crypto space. I went over to Galaxy Digital, which is pretty well known in the space, to build similar platforms and tooling and approaches in crypto that we do for TradFi. So I was the head of quant and data strategy over at Galaxy for their electronic OTC business. And then, I know Matt through Carlos, and, as I said, I'm very happy to be here, and I couldn't choose any other, podcast I would prefer to be on than to be with you, Carlos, and with you, Matt.
Yeah, no, we're pretty excited. One of the things that resonated with me when you were talking a little bit was sort of how the world has shifted into a more data-driven approach when it comes to trading. And I think what's really interesting about you, and I'll maybe go into your background a touch more, is that you have a master's in computational finance. And I think one of the things that's really interesting to me, because this is something that I've had a lot of conversations with people that both have been through those programs or that recruit from those programs, and even with faculty at those types of programs, is that historically, they were very much driven towards, how do you compute options pricing? What about stochastic calculus and how do we solve Ito's lemma and all that sort of stuff? And then now I think the quant finance world has drifted from very complex stochastic calculus derivations of derivatives to, all right, well, we have very simple liquid products, but we just have a fuckload of data, and we need to now develop best practices for numerical analysis on that data. I know that you and I have talked a lot about that in the past, but I'd be keen to hear your experience going through one of those programs, and also kind of what you have learned having come out the other end and been working on the data side.
Yeah, sure. You're taking me back in time about 12 years, but obviously was a big formative time for my career. So I actually had a bit of a non-traditional path. My undergrad was in mathematics, but geared towards actuarial science. I was planning on being an actuary. I actually had 2 internships at a well-known insurance company as an actuary. And then I decided that it was a little bit more mundane day to day than what I really wanted to do. I wanted to be a bit more, I guess, a bit more in the weeds of running a business versus kind of just sitting in the back office and running models. And that was right around the same time when financial engineering degrees were really becoming popular. So this was going back, I think it was 09, 2010. So I went to Baruch MFE. It was one of the top MFE programs.
It still is to this day.
Yeah.
I'd classify Baruch as definitely a top 5 program when you think about the jobs and the resources that are available. I always recommend Baruch as sort of a quiet sleeper on par with what you'd find with, Carnegie Mellon, Columbia, NYU, Princeton, so on and so forth.
Yeah, and the other side of it, not to, I don't want to give the program too much of a plug, but the director of Baruch is very, very engaged and involved with all the students, which is great. So, I mean, placement there. I mean, I really enjoyed my time there. But for me, it was taking the same skills that I learned to be an actuary, the mathematics, the applied math. I was more always on the applied math side, not so much in the, the theoretical maths, but applying it to something that I felt for me was a bit more interesting. So to your point, you talked about options and that being the focus of MFE. I think to a large extent it still is. But there's also some evolution there. So, we know that quant finance is a lot more than just how do you price an option, although that fundamental maths and being able to model is an important skill. But what are you actually going to be doing day to day on the job? There aren't that many quants on the street that are actually sitting there pricing options these days. Most of that's already done. And when it's not, I mean, it's really not a whole lot of work. Pretty much everything these days, people that I speak to, both in e-trading, but even outside of e-trading, it's all about data. Right? And that's,
Yeah, I think regulation kind of killed the exotic option land
Exactly.
after the next financial crisis. That pretty much
I was going to say the same thing.
Yeah. Well, if you go even further back, I think the original financial engineering was actually more focused on structured finance, which was, asset-backed security modeling, mortgage-backed securities. Obviously, in '08, that became, a little bit of a 4-letter word. There's still people going into that space, but it's not, it's no longer, when you think about financial engineering, that's not really what you think about anymore. It's more about options pricing. And then what it really should be is about.
I remember being at the banks and reviewing what Dodd-Frank did in terms of balance sheet treatment for those products. And it used to be that for every dollar in notional traded, you could have some percentage of that on your balance sheet. So you could have trillions of dollars of these notional derivatives out there. They're super high margin. And then in Dodd-Frank, they're like, oh, by the way, you need to have 1,200% collateralization on a lot of these types of structured product things. And then the market for, pricing these exotic derivatives went from being something where every quant in the world wanted to do it. And then it was actually, you know what, we're going to shift towards just vanilla options and spot. And, all the stuff that you guys used to do is now just a function call in a library that we've already built, and we already have it built for the last 20 years.
Yeah. Yeah. So it's one of those things you kind of have to understand it deep down, but if you don't remember it day to day on the job, it doesn't really affect you, right? It's more that you have that fundamental grounding in how these things work. And I kind of like to think of quants these days and financial engineering programs as an extension, as kind of a bit of a Venn diagram, right? So you have quants that are extremely mathematical, right? Very in the weeds on the modeling side, whether that be options pricing or, machine learning or whatever else that is. Then you get people that are much more on the quant dev side, highly technical, writing a lot of code, may not even really understand the models to an extent at all. You don't even necessarily need to go to a financial engineering program to be a pure quant dev. And then you get quants that are much more business oriented, have a good business intuition, but may not really be that quantitative or technical, but they're kind of that bridge between the non-quants and the quants. And then you get
MBA quant here, guilty as charged.
You're pretty technical, Carlos, but maybe a little bit more towards that. But it's a Venn diagram, so people tend to fall somewhere in the middle of those three. And I think to adapt, a lot of financial engineering programs are actually focusing a lot more. I shouldn't say so much on the business side. I think that's still something that needs to, evolve a bit, but a lot more on the technical side than they used to. So, things like C++, Python, data, KDB, machine learning, there's a lot more focus on that now than there was when I went to school. So like a lot of what I've done over the years has actually been things that I've learned on the job because it wasn't really a focus of financial engineering at that time.
Yeah, and I think that there a lot of the focus of those financial engineering programs has changed as a result of people from the businesses coming back and recruiting and telling university staff like, hey, options pricing is cool, all this sort of stuff is cool, but also this is what we do on a daily basis, and you kind of need to steer people. So I've definitely seen a good response from the community about how to prep for the field and then move on from there, and it's been a good roundabout way. But I guess for the sake of time, because you have so much of a wealth of experience when it comes to actually building systems, I'd like to perhaps transition a little bit into what I would call maybe one of your core skill sets, critical things where I think you probably excel beyond most people in the industry, and that is sort of the treatment of data. So I think more than anything, one of the things that I'd really love to get from you is just, I know this is a broad question, so take it where you want, but that's what would you say is your core philosophy when it comes to building out a trading system with respect to data and making sure that that's treated in a pristine way?
I would say two pillars. One is, I like to say, you want to be strategic with an eye, you want to be strategic with an eye on the tactical, which in other words, you want to be commercial. You want to have a strategy on how you want to get somewhere, but don't try to get to that strategy right away. You want to get there in a way that's going to add a lot of value as quick as you can as you're getting there. That's more of a kind of a philosophy that goes beyond just data.
Yeah, but it's called how not to get fired in your first year of working at a place.
Yes, but it also feels good to make progress. I personally find when I'm pushing things to production, it makes me feel accomplished. Whereas if I'm constantly trying to build and perfect something that's just sitting in the background, it starts to get stale and you start to get bored of it. You don't feel like you actually did anything. But then, from a data specific perspective, I think it's actually about, coming up with a seamless data workflow, right? So it's data is important, right? Having that data and that good data, everyone knows what good data is, right? It's data that is as clean as it can be. It has good timestamps if it's time series data, and it's correct data. But to me, a lot of it is about the tooling, the consistency, and the workflow.
By the way, in crypto, one of the biggest things that Matt and I found when we moved over to crypto, not to derail you too much, but I love how you said timestamps, because one of the biggest problems that we saw in a lot of open source crypto software and a lot of conversations we were having with people who were building crypto is just the utter and total lack of awareness around how to keep proper timestamps in data. It's just wow, I can't believe that you have a full market and people aren't really treating this with the respect that it deserves.
And the lack of importance around that as well. I think that goes together, right? Because if you don't feel that it's important because you don't understand the importance, then you're not going to do it well. And I think a lot of that stems from how you use data. So, Matt likes to talk a lot about data being done from first principles. And I'm a firm believer in that as well, right? You should build data into your trading systems, or at least think about proper data from day one. It's not something that you should wake up 6 months later and decide, now that we're 6 months down the road, we're going to now try to think about data and we're going to kind of duct tape it together and, shoehorn it in and not really focus on how we're going to be using that data and how we're going to be, exhausting to it.
Yeah, that's a good point. That's kind of schema design considerations, things like that. How do you tackle the inevitable? You may never. It's unlikely you'll cover every column that you're going to need for analysis going forward. So how do you tackle something like that where you need to add extra data that you haven't foreseen in your original pipeline? Because that's like normally one of the hardest.
So I think the real key there is, like any software engineering, it's doing things at an abstract and generic enough way from the beginning that when you inevitably do have to make those changes, there's a minimal impact to doing it. So that means, minimizing how much you're going to be hard coding in terms of schemas, having a framework that allows or enables you to actually change your schema without having to then rebuild your entire data set. So, KDB, for example, is really the premier time series database that's used in electronic trading. And when done well, right, obviously garbage in, garbage out. If you don't build something well, it's not going to serve your purpose. But if you build it well, KDB is, very easy to, well, I shouldn't say very easy. It's relatively easy to modify schemas when you need to do it. Now, is it something you want to minimize? Yes, but it's all about having that good design from the beginning. And it's really not just at your data layer, right? It's also, when you think about data, you have your initial data layer. You also want to have, okay, what do I do with that data? You're usually going to have some sort of data API that you're going to build on top of that visualizations tooling. You want to make sure all of that is built in a flexible enough way that it's not going to break when your schema changes.
Got it. I think one of the key things, and this is the hard thing to, I think, balance. Like there's the difficult problem is, how do you put something that's good enough, right, and somewhat modular, but also not overthinking it and being too clever, such that you can't actually just fucking ship code.
Yes, and that gets back to that first point, right, which is, you got to get something out right away. You get it out. You always have your eye on that ball of creating something that's generic, but that should never, I think, Carlos, this is, to borrow your line, you don't want to let perfection be the enemy of progress.
Yeah. So that, to kind of go back on this, I think, and I've seen this a number of different times over the course of my career, where they'll have somebody come in and they'll get funding, or they'll get, sign off from management to do something big, right? Like, I've got this new alpha project, or I have this new risk system, or something like that. And then a year and a half to 2 years later, you're like, all right, cool. Where is it? Oh, we're still testing. We're still doing this sort of stuff. We're still managing this thing by committee. And I think the problem that you put yourself when you do that is, when that comes out, that's got to be fucking groundbreaking and really move the needle, because you've just built up such this like massive, expectation around what you've done. Versus, I think if you just come in and you provide a series of quick wins and then continue to build, it's a much more sustainable approach in terms of building out data, building out systems, and providing deliverables in this type of framework.
Yeah, I fully agree with that. And I think to add to that a bit, it's also very helpful because it's never great to be too prescriptive. So at a high level, what works, but every problem gets solved in a slightly different way. And if you come in with that final vision of how you want things to be, and everything has to be about solving that vision, that gives you very little flexibility to do things that are specific to your problem at hand. Whereas if you take things slowly, your vision is probably going to evolve a bit from where it started by the time you get there. And that's a good thing.
Yeah, and you can achieve incremental goals along the way. I do like that paradigm. I was going to ask Avi, so you brought up KDB. What are the main? I like pitching KDB is not what we're about at all. I wanted to ask a little bit more. Why is that your favorite? Why do you think that's the standard? What's the benefits of using that? What is it even?
And yeah, I think just maybe to take one quick step back for those who are listening but are not quant finance natives. KDB is basically the de facto time series database used on most buy side and almost all sell side shops. It's a proprietary technology company. Licenses can be reasonably expensive, so it's usually one of the first things that you learn when you land on the desk. And then once this is my experience of it, once you learn it, there's no going back. It's kind of it's like using Excel for normie finance people, but in quant finance.
Yeah, I mean, KDB is great for what it is. I mean, it's a time series database, and now one thing when you think about databases, right? There's time series, you have cross sectional. KDB solves that time series problem. Things like SQL, great for cross sectional, so that's a separate conversation. So, I don't like getting in kind of like the language wars. I like to think about every language has its purpose, and KDB, when it's for a time series database, is the best in class. And I actually think, and I've seen this, I actually think it's the only in class in terms of its ability to, to handle the amount of data in real time that KDB can, while also giving you, at your fingertips, basically a language called Q, which is a native language to KDB. I'm not aware of any other technology that does it the way Q does and the way that KDB does. And what's really powerful about that is when you think about how you query data traditionally, say you're used to using SQL, maybe you have some tool that sits on top of your SQL database and you're typing in your SQL queries. But when it comes to actually doing things, say in Python, which is where the meat of most analysis actually happens, you're going to be opening up a pipe to, say, a SQL database. You're going to be sending in quotation marks a SQL query over to your database. It's then going to send it back. And now you have that like SQL code living in your Python code. From a design perspective, as I talked about before, like design best practices just go out the window when it comes to things like that. Q is a native language to KDB. So yeah, you can open up a pipe directly into your KDB database and do that sort of query, but it's also very well integrated with Python. So they have technologies called EmbedPy, PyKX, different technologies about using either KDB from Python, Python from KDB, from Q, and you do things natively via the Q language, which is extremely powerful from a design and a workflow perspective, which, as I mentioned, is a big part of my focus. And it's also very fast. So you can do things like as of joins. For those who don't know what that is, it's basically if you have two data sets and you want to, both of them are time series, and you want to join, for example, a trade onto the preceding quote. So very ticky quote data, you have trade data, and you want to find the quotes that happened before each trade. Or taking that even further, a window join, where you want to join a trade, say, onto 60 quotes at some time frame prior or post trade, which is a very common problem in trading. Doing that in any other language without massively parallelizing the problem is virtually impossible. Whereas in KDB, you can actually do that using a single core and do it pretty quickly.
I actually haven't found a comparable alternative that does window join, if I'm honest.
No, I mean, there's some open source that have come along, over the years. And, my answer to those is, one, they're duct taped together. And, I'm not against open source in any sense. I think open source is a great thing. But when you think about something as fundamental as data, you don't want to be building your trading system on a house of cards, right? On something that's not proven, on something that there's no white paper, that there's no books around it. There's no very little in the way of documentation. And if something goes wrong, if you don't know definitively that your data query is going to give you what you're asking it, then how can you build a model on top of that? Right? You have to be 100% certain that what you're querying is what you're getting. And you can't say that about, an unproven open source database technology.
Yeah. I always make the analogy like Excel, right? Because, there's a whole generation of business school kids that learned how to do everything in Excel. And in fact, I had a teacher in B school that was teaching us about basic financial modeling. And he's like, yeah, we focus primarily on Excel in this class because, if you show up to a job and you don't know how to work Excel, that's on you.
Yeah.
If you show up to a job and they don't have Excel, that's on them. And I feel like the same in quant finance can be said of, KDB, right? Like at this point, I would call it the de facto, time series language. It's proven, it's trusted. Every major bank on the street uses it. Almost every major buy-side shop, with the exception of a few notable ones that have put together their own random ass thing for whatever reason, use it. It's just sort of you go with it because, one, you know that it works, and two, you also know that all the people that know what they're doing think in KDB. And so you don't have to hire someone and be like, oh, by the way, we use something that's not KDB. So learn this really weird idiosyncratic thing. take a couple months, like getting yourself familiar with it, and then come back to me. It's just sort of a plug and place.
Yeah, so Avi, do you want to walk us through some of the most useful languages that you've used, and maybe give some points to why they've been the most beneficial to how you've implemented certain design choices for a database pipeline that you've worked with?
So the way I like to look at that is, as I mentioned earlier, I'm not a big fan of language wars. Like, I know there's a lot of people that like to talk about, which language is better.
You have to take a side, Avi. You have to.
I definitely have opinions, but the way I look at it is, I like to use the language that's best fit for the problem at hand. I think where things become a problem, no matter what you choose, because every language has its benefits, right? You'll choose different things for different problems, is when you start to use a language beyond what its strength is. And to give you an example, so to your question, Python is pretty much gold standard right now for data analysis, machine learning, AI. The amount of productivity that you get by using Python compared to other languages for something like that, especially if you're using JupyterLab and you're doing things rapidly and you have all your packages and a lot of the stuff is already pre-worked, your productivity is massive compared to any other language. You don't want to do something like that in, say, Java or C++. Whereas we talked about KDB. So Q is the language for KDB. Q is really, really good at data aggregation. So we talked earlier about as-of joins, being able to do select statements and being able to do that quick. The problem becomes when you start to try to do things like complex data analysis in Q, because you're used to using Q. So you say, I'm going to try to do that using Q and try to get fancy that way. It ends up, it's not ideal for it. So you end up just, you end up having a loss of net productivity. Whereas, the other way around, when you start to use Python for something like that, where you say, I'm doing 80% of my work in Python, so let me also do my data queries in Python. So if you find some way to open up pipes to your KDB, and you do things kind of the old-fashioned way, meaning like the CCall approach of querying from Python, but now you've just given up the entire power of Q. So striking that balance where you use things to their strengths and then bridge them together is what I think is very important. So in terms of specific languages, though, I do think Python is not going anywhere ever. I think Python's at the point where it's as here to stay as C++ is. And that itself may be a bit of a controversial comment. C++ has ebbed and flowed over the years. But one thing that's unchanging is that C++ is still here, 40 years later.
Yeah.
And
it's still the base of a lot of those core ML libraries as well, right? So PyTorch, TensorFlow, all of the C++.
Exactly. And there's a little bit of a misconception that, a lot of people like to learn C++. Disclaimer, I actually have, I've been running a couple online C++ courses for several years. So obviously
He's very good,
C++ is something near and dear to me. But, there's a perception that C++ is just necessary to kind of build your chops. Like, you want to learn how to code, so you're going to use code in C++ in the beginning. And then in practice, you're never going to see it again. And it's only used for legacy code. And that may have been true for a time. You go to a lot of big banks and they have a lot of legacy code in C++, and you're not going to do a whole lot of fresh coding. But if you go to a lot of, newer shops, C++ is making a resurgence. And a lot of that is because C++ features have significantly improved in the last, several years, since C++ 11, 14, 17, even 20. Things that you can do in C++ are, or things that you can do in other languages like Python that you were not able to do easily in C++, you can now do there. So you're getting the best of both. But the other reason is that ultimately it's the most rigorous language. You have the most control. So when it comes to memory management, when it comes to, having that ability to write, for example, a trading system that actually does what you expect it to do, I believe that C++ is the most deterministic. Java is a close second, so I won't totally put down trading systems written in Java. I mean, I've seen good systems written in Java, but I'm a strong believer in C++, and I do find that the best Java developers and the best Python developers are the ones that have a grounding specifically in C++, because it gives you a way of thinking that no other language does. But then off of that, C++, Python, I think KDB is really important if what you're going to be doing is going to revolve around time series data. I think the vast majority of quant work these days does revolve around time series data to a large extent. So then KDB is worth knowing. I've never seen a KDB class in any school, in any college. So,
yeah, neither have I actually. I mean, that comes to a good point though. So you mentioned integration of like Python, say, within another language like Q, so you could train something. Is that fair to say?
Exactly. Yes, that gets down to what I think about as the workflow, right? So a lot of data analysis is done, and people get in bad habits. So, they get used to doing data analysis, say, using one tool. So you have your, to give KDB as an example, there's something called QStudio or QPad, and it's kind of like a notepad which connects to your database, and you're going to be sending your queries there. And people get it, they get used to doing queries from that. And then they also get used to doing their data analysis using data frames in Python. And that's fine, but the problem is you have a disconnect. How do you get your data from that point A to that point B without having to overly context switch, which is, creates a loss of productivity. But more so than that is when you have a pipeline from research and development, R&D to production, how do you do that in a way where you're minimizing the risks at each point? At each point in time, right? So say you do your data analysis and you're doing that in QStudio, and then you're switching over to Python, and you're doing that in a discrete way. So you're exporting your data to Excel, to a CSV, and then you're loading in that CSV using pandas. How do you know nothing went wrong between those 2 points with the data? And then when you're going from that point where you're doing your analysis and you're building your model, and now you've proven it, if you're in a big bank, you've also written your model documents and all that. And then you're going and you're writing something in production that's trying to mimic what you did in your data analysis. How do you ensure that what you're doing is the same? Just to give a simple example, you have, a linear model with coefficients. Okay, it's easy to implement those coefficients into your C++ code, into your trading system. Say you get a bit more complex, you want to do a random forest or something a bit more nonlinear. How do you ensure that what you're implementing in your code is exactly the same as what you tested in your model?
I'm glad you got to this because I wrote down serving a model in production. That was my next question. So how would you go about this? Because this is a big problem that everyone must face at some point.
So at a high level, I mean, without going into implementation specifics on things that I've done in the past, but at a high level, what you want to make sure is that one, you have a single point of data. And this is beyond just research and development to production. This is for everything. So if you think about data consumers, quants are big data consumers. Traders are big data consumers. In every firm, there's going to be other data consumers as well. If you're in a bank, there'll be a sales team. There's always going to be senior management. There's going to be regulatory. Everyone has to look at that data. You want to make sure everyone's looking at data the same way. And that includes not just people, it includes systems, and it includes, front-end tools, and it includes alerts. Everyone should be looking at data from that same point. And that means not just, not just the data source, but also how you're aggregating that data. So the first,
Can I jump in for one? Because this is one of the things that bugged me to know. This is one of my biggest nightmares in the world at a bank is you go through all of the effort to build very pristine data. And you go through all the effort to have like one golden source of data. You build it out, everything's perfect. And then you're sitting on a call with some senior management somewhere, and for whatever godforsaken reason, someone's alternative data finds its way into a PowerPoint. And you're sitting to yourself, it's like, those aren't the numbers. How the fuck did you come up with those numbers? And then the next thing you know, you end up with this dislocation where management thinks like, oh, this is the ground truth. And you can't sign off on those. And so therefore now it's just like, well, your data must be wrong too. It kind of like poisons the well a little bit, because the minute you have inconsistent data or an inconsistent narrative across that data, number one, it casts aspersions on what you're doing. So even like the best and most pure intention of effort to do something like this can often lead to big problems. And that's just for like the human users. Imagine if you have an API that's reading one source of data. Let's say, for example, the API thinks like your trading position is X, and it's actually Y, because you don't have consistent, data across the number of systems downstream that listen to these one source of thing. You can have massive trading problems because you're like, you're trying to hedge a risk that doesn't even exist. And you see this all the time in these large, systems where people don't fully understand the need to have like a uniform source of data it may not be ground truth, but at least it's consistently revered as ground truth.
Yeah, that consistency is probably even more important than ground truth, because ground truth is to a large extent subjective, but lack of consistency is a big problem.
I completely agree with you. Because like, if you're going to be wrong, at least all agree to be wrong together.
I think that's one of our first pillars of data, right? Data is a first class citizen. 99.9% is not good enough. It has to be 100% accurate. And this must be compliant and signed off by business owners. That's like step one.
Yeah.
Or business owners that will be making decisions off the back.
One thing that I think to go back into your like data workflow comparison, because I think this is also true and something that I think you solved exceptionally well when we were together. I know that you've done this before. You've done this in numerous places also. I'm going to paint a picture, which is like at a lot of quant shops, different quants have their own workflow, meaning like you talked about, they pull it out into KDB and they do some stuff with it and they put it into Python and they have all these bespoke types of analyses, and one that is a data consistency problem because you can't ensure your data is done the right way. Then the second thing is a lot of analysis becomes bespoke.
Yeah.
And I think one of the things that you've done exceptionally well, and I've seen firsthand, is create what I would call like an analysis or an alpha generation factory, where you can design a workflow that gives you a totally modular experience from idea of, some analysis to research to productionization in a way that preserves integrity and makes the workflow easier for the people that are doing the work. Maybe you could just talk a little bit about, what you've done there, how you've gone about implementing that, because I think that in and of itself is probably a multi-million-dollar cost savings to any firm that implements these types of things.
Yeah, I mean, the real key there is giving people, and when I say people, so in your specific example, that's other quants that need to be doing, some sort of analysis or modeling around your data, but really any consumer of data, giving them just the right amount of flexibility while also constraining where you don't want liberties to be taken. And that's not because we're trying to be restrictive. It's because we're trying to keep things consistent, to your point. So that's the overarching philosophy, is how you go about doing that. So to your specific example, you think about machine learning, right? Machine learning is actually a fairly cookie cutter problem at first principle, which is you have data, you need to clean that data. Then you need to get into that first round. And, Matt, you can jump in, talk about this as well, but you need to get into that first round of data analysis, visualization, a little bit ad hoc, right? You're going to be probably using some Jupyter notebook or Jupyter Lab, and you're going to be just getting a feel for that data. So at that level, things are pretty ad hoc. So what do you want to limit? Well, you want to limit the general approach that people take there. So you want to make sure people are looking at data the same way as much as possible. So if it's data that people have already been using a lot, you have a data API around it. How do you visualize that data? You want to have a good visualization API that, I'm not using Matplotlib, and, maybe I'm using that and you're using Plotly, or you're using, Seaborn. We should all be looking at data roughly the same way. But it's going to be a little bit ad hoc at that level. Then you get to the next point. Yeah.
Can you really quickly, because I think this is a massively important point, what's the concept of a data API? Because I think that, like, especially at banks and hedge funds that have like data across disparate systems, that to me is like the one thing that I found is the absolute lifesaver when it comes to making sure that things stay routine.
Yeah. So you think about it from like the ground up. The lowest level of a data API would be basic utility functions, things like interpolations, math functions. Then you get to the next level or layer on top of that, which is I have data, say trade data. I want everyone to look at that trade data and query it the same way. So in KDB parlance, you would actually build a queue function, and that would be a parameterizable function. Say it would be called, get trades, and you would put a start date in there, an end date, and then you would probably want to write it in functional form, which gives you a bit more flexibility. but you allow people to basically parameterize that function. But the real benefit of that is data is never perfect. So we talked a lot about early getting that done perfectly in the beginning. Well, it's never going to be perfect. Schemas are going to change, to Matt's point. There'll be other issues that happen over time. There's going to be decisions that have to be made when you select from a table. So for example, quirks in the data. Maybe I need to filter a very specific thing when I'm looking at the data, or maybe I need to aggregate in a very specific way. That gets encapsulated in your API function. So people, and if that,
or maybe even there are known outages in the data that we want to avoid, and like any number of these types of things.
Yeah, data cleaning, all that. So that gets encapsulated in the function. So that way, as those things change over time, every consumer doesn't have to be aware of those changes in order to actually stay consistent and benefit from it. So it's very, obviously very important to have that from a data consistency perspective. And then you take that a step further to to what we were talking about a minute ago, which is, how do you actually take that to the next step and build a machine learning framework? Well, you also want to have consistency on how we build such models. So feature engineering, right? So data cleaning, you want to have consistent functions in how we do data cleaning. You want to have consistent functions on how do we actually do, basic feature engineering. But that cookie cutter problem, which is really, I come up with a bunch of features or potential features using my, ad hoc analysis, and I want to throw a bunch of different models at those features, and I want to quantify the success of those features or how good of a fit the model is. A lot of those are very, very cookie cutter problems, which means you don't have to have people doing different sorts of analyses. You can standardize, okay, this is the metric that we care about. This is the view on that metric. So say you want to look at, over time series, how does your R squared look? How does your ROC, AUC look over time, for your model? All that stuff gets standardized into a framework that everyone uses. And then you have confidence that, if I come out with a model and you come out with a model, that they're being held to the same standard.
Yeah, I think, and I saw this firsthand when you implemented a lot of this stuff when we were at B of A. But I think the natural state of entropy on a lot of quant teams is that quants tend to develop their own personal library of this is how I do an EWMA. And this is as the case in point, I think when we first got to B of A and started working together, every quant on the team had their own version of a pivot table in KDB.
Yeah.
And so you're like, no, hold on, guys, let's just do it once, have an API. If someone has a newfangled or better way to do it, put it into the API. And then now it's exponentially easier for everyone else to do these sorts of things. So you get two benefits from this. First is that, all this boiler, the easy stuff that you don't really get paid to do. What if we do a expanding time series cross validation? Cool. You build that once and then everyone on the team gets access to that. So now you can exponentially improve your productivity. And then the most important thing is that now all of your analysis is consistent.
Yeah.
And somebody didn't make a mistake in the way they did something that gave them a better result. So you're all speaking in the same language. You're all using each other's tools. And as a team, the power of building that exponential sort of growth in your productivity is absolutely astounding.
100%. And it allows everyone to keep their eye on the ball, which is the most important thing. You don't want to get bogged down every day in, how do I reinvent the wheel on things that you've done 10 times and have been done 20 times, not just by your team, but really across the street.
Yeah, no, I think that when you have a good data environment in place and when you have a good research framework in place, what you find is that tasks that used to take you an entire day are now a couple function calls.
Exactly.
And even the cognitive interpretation of those results, when you're looking at charts that you've looked at a bunch before, all of a sudden it's oh yeah, I know exactly what that is because I've seen it before, and my brain has established those pathways to look at those charts and think in terms of those metrics. It's a super valuable tool that I don't think a lot of people fully exploit in terms of their ability to unlock productivity in their quant teams.
100%.
So I think I sort of hijacked the conversation and brought it towards something that's near and dear to me, which is this quant workflow and unlocking more productivity out of the team. But I guess, what are some of the biggest pitfalls? So if we were to say, things that you've walked in and you've seen being done, and you're oh my God, the fuck are you doing? Or maybe even not even what the fuck are you doing, but hold on, think about it this way, in a little kinder way. And if you can avoid this, you'll save yourself months and months and months of, hassle down the line.
So I think some of the, I guess, most important decisions that you want to make early on, right, which is how you avoid those sorts of pitfalls. Is, we talked a bit about data, data from first principles. So on day one, you want to at the very least be storing your data somewhere, because the last thing you want to do is wake up 6 months later and you build a data framework and realize that you have no data to backfill. Now, granted, it's not necessary, depending on what you're doing, you can possibly live with that loss of history, or you have some other way to build that history. But having that data up front is definitely a good thing, especially when you think about, we talked earlier about doing things tactically first. Well, if you have some data to work with, then you can actually do things tactically. Whereas if you have no data to work with and you're going to first start building 6 to 12 months of data, you kind of have to sit on your hands for 12 months before you can do anything useful with that data.
And there's another point to that, which is, for example, the difference between first principles data and derived data. If you have the option to save the first principles data or the raw data itself, it's almost always better. Because I can think of a number of times over the course of my career where we've chucked out the raw data, we saved the derived data, and then 6 months down the line, we're like, oh shit, we forgot this really important feature in the derived data. Let's go back and recalculate it, but you can't because you've chucked out all of the raw data.
And, on a slight tangent, this is actually why, crypto is obviously a growing space. And you're seeing a lot of traditional finance talent moving into the crypto space, as I did, and as you both did as well. And I think that a lot of that knowledge of what are you going to need down the road is entrenched in traditional finance. And what I've seen, I've talked to a lot of people, different firms, in the crypto space, and, the people that have more of a presence, or that traditional finance presence, have a better head start when it comes to data. It's like they knew on day one, just intuitively, that we're going to need market data. So let's start saving it right now. We may not be able to afford KDB today. All right. We may not be able to do what we want to do in terms of derived data today, but let's start saving it down because we know one day we're going to need it. And other related sorts of decisions, like just the concept of data from first principles is a little bit far and outside of finance. Right. I mean, obviously there's other fields that are very data driven, but crypto traditionally, I guess early on it was just not as data driven. I mean, correct me if I'm wrong. My sense of it is it was a bit more ad hoc from a data perspective than finance, traditional finance.
I think that it comes down to there were such easy ways to make money in earlier iterations of crypto that you didn't need to be as detail oriented versus in traditional markets. If you're not detail oriented to the nth degree, there's just no way you can make money because all the easy money's gone.
Yeah. That makes a lot of sense. And as the opportunities start to close up, you then have to start being a lot more rigorous. I think another big point. You asked about pitfalls. Another big pitfall that I've seen is getting consumed with the next best technology. I've seen this pretty much everywhere that I've been and everyone that I've spoken to that's been places, which is people get hung up on, what's the nicest front end and what's the nicest GUI and the coolest back end technology. You hear a lot about Spark. I don't want to go into, other open source technologies or other non-open source technologies. The problem there is you get too hung up on the specifics of how you're going to be delivering data and too hung up on technologies versus what you're actually trying to do. And, when you have a proven, battle tested workhorse, like something, like KDB or like C++, Python, other languages that are entrenched, you don't want to get bogged down in kind of the next best thing. I don't think I've ever seen it work. It always 100% of the time converges back to what people know works. So why waste that time and money in the first place?
Yeah, I think that's a great management principle for anybody who is, taking over a team of quants or engineers. And that's quants and engineers, I think, have a natural default, and this is a beautiful thing about them, to want to go down the rat hole of chasing like the next coolest thing. So like they can see something that's perfectly normal and be like, man, I could make that a little bit better by doing this one thing. Or I read this article about like a new, back end tool, and they want to like jump in and rip everything out and build it, because that's just the nature of an engineer. And so you never want to get rid of that. But I think 99% of the job of a manager of engineers or quants is to say, no, stick with what works. Let's get something out the door. Later on down the line, we can explore this sort of thing. But like what we really get paid for right now is delivering immediate value.
Yeah. And there's just so many fintechs out there right now. All right. There's just so many of them. There's always another. I mean, you can probably speak to a new fintech every week.
Yeah. I think, this is a fun thing too, which I know you and I had some very, 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 amazing debates about this, because I think this is true of a lot of fintechs, is that in the world of banking and whatever, there's some new fintech that's approaching you to be like, oh, we're going to revolutionize the way that you store data. We're going to revolutionize the way that you serve out, dashboards to clients. And the one thing that always just like totally appalled me is each one of those fintechs requires you to replicate your data in their own ecosystem. Yeah. I think there's some sort of like SaaS playbook where their venture capitalists tell them, it's like, no, you want to get the data in the door. And once it's there, it's sticky. And it's like, no, well, then it's unusable, because now I'm copying over terabytes of data into, your BI tool or your, different way of like doing something. Also that we can have a slightly cooler JavaScript front end. It's like, this is completely and totally
I know.
useless.
And to my first point that I made, which is software engineering principles going out the window, because that concept of separation of concerns, or you don't want to be tightly coupling your business logic and your front ends and all that. That's what these technologies, by and large, with exceptions, but that's what they do. And, obviously it helps them because, they have a technology, and once you're entrenched, it costs a lot of money to get out of it. But even if it's a great technology and you say, okay, it's worth putting my data in there, the problem there becomes, well, you've solved a subset of your data problems. Maybe it's a big subset, maybe it's a small subset. But the problem is that you've only solved a subset. So for example, say it's a trading tool. It's a great front end that's going to give traders, a great view into their book and P&L and all that by giving them your data. Well, as a quant, I can't use that trading tool because I need to actually be with the data, and I need to use the tried and proven tooling for that. So now I have a disconnect between what I'm doing to the earlier points we made to what the traders are looking at. That's a big problem. I don't want my business logic ever, and it's not because it's proprietary. I just don't want my business logic living on those tools, because now I have those disconnects that I was trying to avoid. I want my tooling to be on top. I want my front ends to be on top of my data API and my data platform, so that if I decide tomorrow that I want to switch to a different GUI, there's actually very little effort to do it, or relatively little effort to do it. And also, we're all ensuring that we're looking at data the same way, and you're not creating those disconnects. And for whatever reason, people just lose sight of that. And, it's not clear to me why, but.
Yeah, no, I think that's, It is always shocking to me, and I think that like I've been the Mr. No angry person at a lot of different places, because that tends to be like one of my biggest sticking points. Is like, no, like why am I going to rewrite my data infrastructure to get it shoehorn it into a slightly better GUI or something along those lines? Yeah. Because to me, the integrity of making sure that like your data is consistent and unique, and if I decide to make a change to that data, or toggle it in some way, or if there's an outage somewhere, or if we need to do something, I want it to be consistent across all the different end consumers of that data. I'd say that's something I knew, but like I don't think I've ever seen anyone do it as masterfully as you have done it. So that's one of the reasons why, obviously, we wanted to have you on the podcast to share your knowledge. I think we're coming up on time, so I want to give you any last words that you have in terms of things that you think are important for aspiring quants and or people just getting started in crypto, as it relates to how to treat data, how to better sort of sharpen your skills in that arena.
Well, the number one thing, and I say this all the time to my students, in my programming courses, which is practice. Right? You have to actually do it. You can read books. You can, find toy problems on the web, which by and large are just toy problems. You want to actually find real life use cases and implement that. So whether that means doing it on your own or actually getting a job and allowing a big part of your focus to be data is very important. And, not just your focus, not just being someone that actually gets in the weeds and now analyzes data, but also, be involved with the actual building, assuming it's not already there, of these frameworks and of these workflows. I think, Carlos, you talked about my success in doing this. I think a large part of that is I was also a big consumer of the data as a quant and doing these analyses along with you and others. And I think that gives you a unique view on what are the best ways to do it, where, a lot of the time you're going to see people off on the side trying to dictate or, come up with something that's not really fit for purpose for what you're trying to do. So the flip side of that is I think being involved with that is important because A, it gives you an intuition on how these things should work, and B, will help you actually with your day job of your data analysis or whatever else you're doing.
Yeah. I think that's all fantastic advice. I think one of the biggest, there's this great Mike Tyson quote that says everyone's got a plan until they get punched in the mouth. And I don't think there's anything more true than that when it comes to quant finance, where, in school and when you're looking at stuff online, you always get handed clean data sets. And you think it's just as easy as popping it into the most recent sort of neural network or whatever, and whiz bang boom, good stuff comes out. But when you're actually in practice, you find that the way that you make your money is handling all these weird sort of esoteric problems that come up and treating that with integrity from a data and modeling perspective.
Well, as the saying goes, you can make data say whatever you want it to say, but when it comes to making money, unless your data is actually telling the truth, it's not going to help you.
Yeah. No, it's so true. I know that we're coming up on the end of time, so I wanted to give you then one final thing to tell everybody. I think, maybe a quick disclaimer on this, which is when you want to bring on really quality guests in the world of quant finance, it's very difficult because people often have sort of walled gardens in terms of how they can speak with me. I remember when I used to work at banks and all of my friends that work on the buy side were like, man, I'd love to be on the podcast. I just can't. So that being said, I do know that you have, either this course and some other things. If you'd like to tell people where they can find you or where they can find some of your work, would love to give you that opportunity.
Yeah. So there's a couple of great C++ courses that they're pretty well known within the student quant community, at this time, but its focus is in quant, but has helped many other people. C++ courses as well as a Python course on quantnet.com. The C++ courses I've been administering for upwards of a decade, and there's nothing like code reviews when it comes to learning to code. A lot of courses will teach you syntax, give you some toy problems, but you don't get good code reviews. These courses will give you code reviews as if you're actually writing code for production, which is very important. And then the Python course is something that I actually put together several years ago, based on my experiences using Python specifically for data science. Very practical course, goes through Jupyter Lab, pandas, Plotly, many different visualization tools. Very, very practical courses that are, they'll be really good to kind of get your feet wet and get in the door.
Cool. No, I can't advocate highly enough for people to look out for good content created by people who are actual practitioners. It's one of the reasons why we started this podcast, and obviously it's one of the reasons why I think anyone who takes a look at that is going to be pleasantly surprised. Avi has a wealth of experience actually implementing this stuff on the ground and in scenarios where you're required to make money.
We'll put a note in the show notes as well.
For sure. All right, boys. Well, on that note, have a great rest of your week. It was a pleasure having you, Avi, and we'll catch you on the next episode of the Deep Q Cast.
Likewise. Thanks for having me.
All right. Bye.